Hey, good afternoon. So I wanted to take some time for everybody who's not been here so that you can get some examples and a look at how to solve some of these problems in this ALEKS assignment that I've given you called rational and irrational numbers. Okay. So to work through this and get your credit, I'm going to give you examples as to how I solved the problem, and then you can do a slide. And since these are notes, and I believe that in notes you should get credit for doing them, as long as you get above a 70% on each of the activities that follow after I show you how to answer the question, then you'll get your free points for that. But you need to pay attention. So what I would recommend doing, watch me do the lesson, then pause the video, go answer the questions, and then you watch the next section. All right. So the first one we're going to talk about is each number an integer? Remember that an integer is a positive, negative, or zero number with no fractional parts, meaning there's nothing after a decimal point or like a mixed number attached to it. So the first one we look at is 51. Is 51 an integer? It's a positive whole number. Yes, it is. This next one, the negative 5 divided by 5. So this one is a little confusing. A lot of times people see a fraction and they automatically assume it's not an integer. But remember, if the numerator and denominator, if the numerator is not smaller than the denominator, and we're just talking about the absolute value, the distance from 0. So for example, in this one, okay, we'll look at 0. You have 1, 2, 3, 4, 5. There's negative 5. 1, 2, 3, 4, 5. There's 5. See how this is 5 units from 0 and that's 5 units from 0? If they're the same, or if the numerator's absolute value is bigger, you're going to want to divide that. Use a calculator. It's fine with me. But if you do 5 divided by negative 5, that would be negative 1. The result is negative 1. Okay. Is that an integer? Yes, it's a negative number with no fractional part. So that would be 1. This one, negative 63 divided by 9. This again gets back into what I'm talking about. Negative 63 is much, the absolute value, its distance from 0 is 63 places to the left. And 9 is only 9 places to the right. So in this one, you'd want to divide. And again, 63 divided by 9, that gives you negative 63 divided by 9 would give you negative 7. Is negative 7 an integer? Yes, it is. And then this one, negative 66.17, is that an integer? Okay, that's what I'm talking about, that no fractional parts. There's 17 hundredths remaining. No, not an integer. And then this one, negative 4 divided by 9, same thing. Is that an integer? No, it's not. Okay. So what I want you to do is go ahead and pause this video, move to the next slide, and you'll have 5 numbers, and you have to answer if they're an integer, yes or no. All right? See you in a few. Okay. This next one, you have to check all statements that are true. In ALEKS, you'll actually check these boxes. For this Nearpod, you'll answer in the multiple choice. Okay, so it's true or false. So remember, in this, we're looking at rational and irrational numbers. So rational numbers, right? Rational number as long as I can write a ratio of A over B where A and B are integers, which we just reviewed what those are, and B does not equal 0, then it is a rational number. Anything else is irrational. So, since it's a ratio of 2 integers, 10 over 4 is irrational. Well, again, is 10 an integer? Is 4 an integer? Yes. That's not a true statement, so I would not check that box. Next, since 5 is not a perfect square, the square root of 5 is irrational. We've talked about irrational numbers. Remember I told you square roots of non-perfect squares and the number pi, those are your irrationals. So remember, the square root of 5 means what number times itself equals 5. Okay, well, think about this. 2 times 2 equals 4, and 3 times 3 equals 9. 5 falls between 4 and 9, but there's no integer that falls between 2 and 3, right? So that number is irrational. That's a true statement. All right, since it's a terminating decimal, 9.3 is rational. Well, anytime a decimal terminates or repeats, it's rational. So since it's terminating, that's rational. Terminal. Combine those two words, bad. All right, since it's a repeating decimal, 14.56 repeating is irrational. Like I just said, if it's a repeating decimal, it's a rational number. So that is not a true statement. I would not check that box. And then the last one, since it's an integer, -10 is rational. Remember, anytime a number is rational, okay, integers and whole numbers fall in the rational number family. So every integer is a rational number, not every rational number is an integer, okay? So, and then this last box, none of the above statements are true. Again, is that a fact? No, not at all. So for this next slide, you'll be given these choices, and then you will select if it's true or false. So go ahead and pause and move on to the next slide. Okay, here, determine if each number can be written as a fraction and state the reason. Okay, this gets back into what I was just talking about. So, if I can write it as a fraction, and all fractions will either terminate or repeat. Okay? If a number doesn't terminate or repeat, it can't be written as a fraction. So if we look at this, 0.74, can this be written as a fraction? Yes. Why? Terminating decimal. Okay. 0.3 repeating, remember that bar means repeating. Can that be written as a fraction? Yes, it can. Why? Repeating decimal. 0.111, okay. I hate this question. I don't really like the fact that they'll do this, but I've seen it on air tests. I've seen it on a lot of standardized testing. I think it's designed to trick you up. This is the same digit, and these three little ellipses mean that it continues on with that same pattern over and over. Nobody ever in math notates it that way. We always write repeating decimals this way, but sometimes you might see it that way. So in this case, is it a fraction? Yes. Why? It's a repeating decimal. The last one, if you look at this, there's a difference between here and here. The difference, this has the same digit repeating over and over. If you look here, is there a pattern of digits that repeats over and over? 257, 963, no. Is there one single digit? No. So can that be rewritten as a fraction? No. Why? It's a decimal that neither terminates nor repeats. So if you see a non-terminating, non-repeating decimal, most of the time it's written like this, where it's just a bunch of random digits with nothing that repeats a pattern, right? It's not the same number over and over, or it's not like something like 0.128, like something like that, okay, where it's the same pattern of numbers that repeats, okay? So that doesn't happen, all right? So go ahead and pause, and then you can answer that on the next one. Okay, here, write 47 over 100 as a decimal. This is pretty simple. Remember, after a decimal point, you have after every decimal point, you have a decimal point. Oops. A little bit bigger. All right. You have decimal point. You have tenths, hundredths, thousandths. Tenths, hundredths, thousandths. So all you do here is, okay, there's 2 and it's over 100. So this would be written like this, 0.47. If it was like this, like let's say you had 8 over 10, okay, that would be 0.8. It's in the tenths, 8 tenths, 47 hundredths. If it was in the thousands, if you had something like this, 235 over 1,000, you would write that 0.235. Okay. So go ahead, and the next one's going to be a short answer. All you have to do is type in the decimal number. All right, go ahead. Here, this is a little bit different, but in this one, you have to write it over 4 and 5. Okay, so this first one I'm going to show you is 4 over 5. So if you remember, you can always make a new fraction by multiplying numerator and denominator by the same number. One way to convert fifths into an easy-to-way right decimal is, think of it this way. What number would you have to multiply by 5 to get 10? I hear most of you right now saying 2. Right, 2. And if I multiply the bottom by 2, I need to multiply the top by 2. So I would have 8 over 10. which means I would have, again, 0.8. There's 8/10. Okay? Basically, anytime a fraction is over 5 and you want to find out its decimal representation, you just multiply the numerator by 2. You know 5 times 2 is 10, so whatever the numerator times 2 is, that's the decimal number. Now, 3/4 is a little bit different. Obviously, there's nothing I could multiply 4 by to get 10. 4 times 2 is equal to 8. 4 times 3 is equal to 12. I can't multiply 4 by anything to get 10, but what I could do is I could multiply something by 4 to get 100, and that would be 25, okay? Quarters of a dollar kind of thing, right? And then 3 times 25 is 75 over 100, and that would be written like this, 0.75, okay? So go ahead and pause, and then you can answer the next slide on your own. Okay, last one, classifies rational or irrational number. This one's pretty easy. Again, as long as I can write it as a fraction, or, it's got a terminating, repeating decimal, it's an integer, it's a whole number, then it's rational, and everything else is irrational. Irrational numbers, again, are always going to be like square roots and non-perfect square, or pi is going to be involved. So the first one we have is square root of 30. All right, is it rational or irrational? Well, think about it this way. 5 times 5 equals 25. 6 times 6 equals 36. 30 falls between there. There is no number that I can multiply by itself to get 30. That is an integer at this point. And remember, to be rational, you have to be a ratio of 2 integers. There's no integer I can do. Irrational number, you're done. 37.26, that's rational, it's a terminating decimal. Square root of 4, 2 times 2 is 4, rational number. Negative 96.25 repeating. Repeating decimals, always rational. And then last one, negative 14 times pi. Rational or irrational? Irrational, pi is involved. That's it. All right, next thing you'll go through, they'll give you a number. You'll answer the question, is it rational or irrational? Go ahead, pause the video, work on your own. All right, this last one, I'm going to go through and go here. All right, so what you're going to do is you're going to build a Venn diagram. First thing you want to do is remember, whole numbers are here, integers are here, rational numbers are here, and then irrational are there. All right, so boom, you use all those. And now you just have to classify them, okay? First thing I see, negative 3 pi, that's irrational, done. Square root of 10, again, no number multiplies by itself to give you 10. So boom, irrational. 0 is a whole number. Negative 69 is an integer, not a whole number, because whole numbers can only be positive. Okay, integers can be positive or negative. And then the last one, 8 divided by 3. Does 8 divide by 3 evenly? No, it does not, but it's a ratio of 2 integers, so it's a rational. Okay. So again, you'll do the same thing. It'll just ask you, the blue circle is here, maroon, green, and black. All right, that's what I called them. And then you'll classify each number. You'll understand it. And there's a picture of this that you can click on each time. And last slide. Again, true or false. Think back to that last Venn diagram that we just looked at. So no irrational numbers are integers. That's absolutely true. You cannot be on the irrational side and be considered an integer. All whole numbers are irrational numbers. That's false. Whole numbers are rational. You saw that on the last one. Some whole numbers are not rational. False. Cannot be a whole number. All whole numbers are rational. Not all rational numbers are whole. And then lastly, some rational numbers are not whole numbers. Some rational numbers are not whole numbers. That's true. 1/2 is rational. So again, think back to that. You had whole numbers, you had integers, and then you had rational numbers, and then you had irrational numbers. All right. So keep that drawing in mind. All right. So this one you'll go through, same thing, statements, answer true or false. All right. That's all for this video. You can watch that. And then you can go through, do the Nearpod on your own and get started on that, Alex. Okay? If you have any questions, shoot me an email. Be happy to help. All right? Have a great day.